Gators, this is 7-3, proving triangle similar. I can use dilation and rigid motion to establish triangle similarity theorems. Similar figures can also be defined in relation to a transformation. We have done rigid before, where we use translations, reflections, rotations. When we want to involve similar figures, we're going to add another transformation, and that's called dilation. Let's take a look at two figures that are similar. We have this similar symbol here, not a congruent symbol. And polygons are similar if their corresponding angles are congruent and the ratios of their corresponding sides are proportional. So they have the same shape, but not necessarily the same size. Let's take a look to decide whether these two triangles are similar. Remember, all angles of this triangle will have to be congruent to all angles of this. Now this adds up to 100, so this has to be 80. This adds up to 100, this has to be 80. So right now we have one of the requirements. We have corresponding angles are congruent. Now in order to be similar, we have to look at the sides. So I'm going to look at the shortest side, which is 24, and compare it to the shortest side over here, which is 30. Compare the in-between 32 with the in-between 40. Compare the longest, which is 36, to the longest over here. Now I'm going to take a minute to reduce. 6 goes into here 4 times, 6 goes into here 5, 8 goes into here 4 times, 8 goes in here 5, 9 goes into here 4 times, 9 goes in here 5. So I can see that corresponding sides are proportional. And with these two requirements, I can say the answer is yes, these are similar. That's by the definition. Let's go ahead and again use this idea of similarity. Let's write the statement of proportionality, and the statement of proportionality will tell us how the sides are related. So the first two letters, BT all over ET, and is equal to the second two letters, TW over TC, and the first to the last, BW to EC. So that's, we write the statement of proportionality. Next thing is to try to find TEC. TEC. Now angle E has to be the same as angle B. So here's angle E we're looking for, and all we got to do is look at angle B. Angle B is 79 degrees, and so that's what angle E will be. Now we want to figure out what ET is, so let me go ahead and substitute the values. BT from B to T, that's right here, B to T is 20, so this is 20. ET is what I'm looking for. I'm going to go over here to BW because I have something on BW here. I'll have it 12, and then EC is 3. I'm going to cross multiply. That'll be 60 is equal to 12 ET, and then I'll divide both sides by 12, and I get the answer 5. So this length right up here is 5. I have a 5 right here. And then BE, which is this length right here, has to be 15, so that 5 and 15 can add up to 20. There is a shortcut to figuring out whether triangles are similar. We don't have to establish all the sides and all the angles. So let me go ahead and talk you through the shortcut angle-angle similarity. We have these two triangles, and all we know is these two angles are congruent to these two angles. What I'd like to do is I'd like to make this triangle bigger. And how will I make it bigger? Well, I'll use a scale factor of this length, which is RS, over this length, which is AB. And it's going to be a number bigger than 1. And this number bigger than 1 is going to make this triangle bigger. And so that's what's going to happen. I'm going to make the triangle much bigger. Now that it's bigger, I know that this green is now this length, this red length. So this red length is the same as this, RS. And this angle here and angle R are the same. This angle B is also the same as S, because when you do a dilation, the angles don't change. And because I have this situation happening, I have angle side angle. So this triangle right here will be congruent to this triangle right here. And now I have established that just knowing two angles of one triangle congruent to two angles of another will establish that those triangles will be similar. They'll have corresponding sides in proportion and corresponding angles congruent. Okay, this is called the angle-angle similarity theorem, and this is how we write it right here. And so anytime you see two angles of one triangle congruent to two angles of another, you are going to be able to say the conclusion is they are similar. Let's determine whether these two triangles are similar. So I have two angles here and two angles here. Let me try to figure out the third angle. And the third angle, 180 minus 39 minus 72. That angle will be 69. And I can already see I won't have a match. I have an angle pair, but I don't have two angle pair. So I'll have to say no. Now let's take a over here. Now we know that these two angles are 60 and these two angles. So we can say yes, and we can say it by angle-angle similarity. We have two angles of one triangle congruent to two angles of another. We know the triangles will be similar. The triangles are similar. These two triangles are similar. Find the value of the variable. So we know these triangles are similar by angle-angle similarity. Angle-angle similarity. Triangle ABC is similar to triangle. Now A goes with D, D, E, F. Now I could write out the proportion, right, between the sides. So what I was showing before. And then I can just substitute values in here. AB is P, and DE is 7, and BC is 16, and EF is 8, and I can cross multiply, or I can reduce right away if I want. So I can go 2 over 1 and then cross multiply, and so P will be equal to 14. So this answer will be 14. These two triangles are similar by angle-angle similarity. So I can say triangle MNO is similar to triangle to PQR, and we know that MN, the statement of proportionality will be MN, first two letters to first two letters there, equals, and then MO to PR. Those are the sides I want to use. MN is 7, PQ is R, MO is 11, and PR is 4. And so I'm going to cross multiply. That'll be 28 is equal to 11R. So R will be equal to 28 over 11. So it's not a very nice number, but that's what R will be. Let's take a look at a proof. Now here we have angle S congruent to angle W, and that is going to be an angle that we have. Remember, the only way to prove triangles similar so far is angle-angle similarity. Then they tell us that this angle right here is congruent to this angle here, and the reason is vertical angles are congruent. That is a theorem we had, so that's another angle. And so now that I have two pairs of angles, I can say the triangles are similar by angle-angle similarity. Let's do one more here. We are being given two pairs of congruent angles. So we have a pair of congruent angles, and then I have to write the other given. Oh, this is given. And then I'll write the other given. Angle I is congruent to angle L. That'll be another angle pair. And remember, we only have one method to prove triangles are similar. That's angle-angle similarity. And so that's the method I'm using. And we're not quite done with the lesson, but so far this is the only method we have to prove triangles are similar, a shortcut method without us having to go through a lot of work. Angle-angle similarity.